Hi guys, we're starting our third type of factoring, which is called the Xbox method. If you're using lined paper, go ahead and write Xbox method at the top of it as the title. If you're not using lined paper though, if you're using our factoring book, we're gonna do the Xbox method right down here at the bottom, right above box method. So yesterday we learned box method. So today we're doing Xbox. And then you want to write the number 3 on the side. So Xbox method is for trinomials, things with 3 terms. 3 terms. And then once you've written down that title, go ahead and open up to that section. We're going to do a total of 5 examples. You can do all 5 examples down here on the bottom. And then at the top, we're going to write down how to Xbox. So when we're doing an example, do it down here. And when we're telling you how to Xbox, do it up here. All right, let's get started. We're actually going to start with an example, so you can start on the bottom page. And so here's a trinomial. A trinomial has 3 terms, and it has to be in a very specific format. So it has to be in descending order, where it goes x squared, x, just a number. And we're going to use a method today called Xbox. So as you can see on my screen, I've already drawn an X and a box. It's the same box that we were using yesterday, the 2x2 box. And then I have my X, and we're going to do the X first and the box second. To do your X, what you're going to do is you're going to do the first number, not letter, number. Now the first number is a 1 in this one, times the last number. So 1 times 32, and we're going to put that on top of the box up here. And then you're going to take your middle number, and you're going to put it on the bottom of the box down here. So the first times the third on top, and the middle one on the bottom. And we'll write all that down later. I have a slide that tells you how to do that. Right now, we're just practicing. Once you have those 2 numbers filled in from the original problem, you are going to try to discover the side numbers on your own. So this is where you have to start actually figuring things out, and you can't just pull them from the original question. Your goal when you're doing the 2 side numbers is to find 2 numbers that multiply to make 32 and that add to make 12. So multiply to the top and add to the bottom. In this problem, my 2 numbers are going to be 8 and 4 in no particular order. It doesn't matter which one is on which side. Those 2 numbers are going to help you take your trinomial and make it into a polynomial, something with 4 terms. Because if we're going to use our 2x2 box down here, we need 4 things to put into it. So what we're going to do next is we're going to take the middle term, 12x, and we're going to split it into these 2 numbers here, 8x and 4x. So it's almost like uncombining, right? Like 8 plus 4 would combine to make a 12, but we want them separate. We want them separate so that we have 1, 2, 3, 4 terms that we can put into 1, 2, 3, 4 boxes, okay? If you don't want to write out the 4 terms right here, what you can do for filling in the box is you can take the first term from the problem and put it in the first box. You can take the last term from the problem and put it in the last box. And you're going to take the middle term, and again, we're going to split it up into an 8x and a 4x, and those go on the diagonal. So the middle term split up goes on the diagonal. And again, it doesn't matter which one goes where. You'll get the same answer either way. Now, we learned how to do the box method yesterday. The box method says we have to look at the top 2 boxes, the first row, and find what they have in common and factor it out to here. So an x squared and an 8x have an x in common, so I'm going to write an x out here. Then we kind of work our way around the box. So next, I'm going to say x times something makes x squared, and that would be x times x makes x squared. Then I'm going to say x times something makes an 8x, and that's x times 8 makes 8x. Moving down to the second row, something times x makes 4x, and that something is a 4. And then we double check just to make sure we did everything correctly. And 4 times 8 is 32. So we did a good job. And then our final answer again is taken from the outside of the box. We'll have one parentheses with an x plus 4 and a second one with an x plus 8 in no particular order. I even wrote the x plus 8 first and the x plus 4 second this time. This is our first example. Again, hopefully you wrote that down here somewhere. Let's try one more example together, and then we'll write down the generic rules for how to Xbox. Again, I'm going to start by taking my first number. Now I have a first number this time, it's 3. So I'm going to take my first number, 3, and I'm going to multiply it by my last number, which is technically a -8. So 3 times -8 will make a -24 up here. So it is possible to get a number on top of the x that was not actually in the original problem. For the bottom of the x, you just straight up take the middle term, which was a +2. You do need to pay attention to your signs. Now in this question, I need two numbers that multiply to make a -24. And to multiply to make a negative, I'm going to need a positive number and a negative number. Now, when you're adding a positive and a negative, you're going to actually subtract them. So because my top number is negative, because I need a positive and a negative, I'm going to think of two numbers that multiply to -24, and then they're going to actually subtract to 2, because one will be positive and the other will be negative. We do want them to subtract to a +2, so you have to pay attention to which number is positive and which number is negative. And those two numbers are 6 and -4. 6 times -4 is -24. 6 minus 4 is 2, okay? Now, again, you can write this as 4 terms and then fill in the box, or you can just do first term in the first box, last term in the last box. Notice that I'm taking them from the original question. I'm not using this -24. And then on the diagonal, I take my two numbers from the x, and I put the letter A next to them because this middle term had a letter A. So 6a and -4a. And those two can be changed. Those don't matter what order they go in. Starting with the top row, 3a squared and 6a have a 3a in common, so I will be factoring a 3a out here. 3a times a makes 3a squared. 3a times 2 makes 6a. And a times -4 makes -4a. And we double check really quickly. -4 times 2 is -8, so we did a good job. My final answer is 2 parentheses, 3a minus 4 and a plus 2, or the other way around. This was our second example out of 5 total, okay? Now at this point in time though, I wanna make sure that we write down in our notes exactly how to Xbox, because again, we will be factoring for the entire semester, and so if you forget how to Xbox, we wanna have the rules written down. If you're using your factoring book, we're gonna write this at the top of the factoring book, how to Xbox. All right, so in the Xbox method, on top of the X, we do the first number times the third number, and on the bottom, we put the second number. We are just putting numbers on the X, we are not putting any letters. Then we need to think of two numbers that multiply to make the top number and that add to make the bottom number. And we have to figure those out on our own. We write those on the side. From here, we fill in the box, first term in the first box, last term in the last box. And on the diagonal, we take the two numbers from the x. And we want to put the variable that was with the middle term with those, both of those. If I'm going too fast, remember you can always pause the video to write everything down. Now with our letter x, depending on if the numbers are positive or negative, there's actually 4 different scenarios that we can run through with positive and negative numbers. So that's the next thing I want to talk to you guys about. In our first scenario, the top number is positive and the bottom number is also positive. If the top number is positive and the bottom number is also positive, then on the sides, you're going to get 2 positive numbers. I've also written a little reminder at the top of the screen. This is done after you've checked for a GCF. So remember, GCF was the very, very first video, and we said that GCF can be done for every type of problem, which means it can be done for trinomials, for polynomials. Later, we'll learn binomials. Anything can be done with the GCF. So check for a GCF first, then use your X. All right, scenario number 2 has a top number that's positive and a bottom number that's negative. So in this one, we have to have two numbers that multiply to make a positive, but that add to make a negative. And so if I wanted to multiply to make a positive, they have to be the same sign. And so I'm going to make them both negative. A negative times a negative makes a positive, and a negative plus a negative makes a negative. Our next scenario has a negative top number and a positive bottom number. So we just did one like this. When you have multiplied to a negative, you need one of each, one positive and one negative. If I want my final answer for the adding problem to be positive, then I want my bigger number to be positive and my smaller number to be negative. And then our final scenario is the opposite of that. So I've got a negative on top and a negative on the bottom. So the negative on top will give me one positive and one negative. And if I want my adding answer to be negative, then I want the bigger number to be negative. The sign of the bigger number will always tell you the answer of the adding problem. So this is every scenario that can happen with the letter X, with your positive and negative signs. Remember, pause the video if you haven't had a chance to write all this down. We have 3 more examples. So here's my next example. Now, before I start this problem, I just said on the previous slide, we should check for a GCF. And this problem does have a GCF. Every single term is divisible by 3. So I'm going to start this problem by factoring out a GCF, which is the number 3. And that's kind of nice because it makes my numbers inside my trinomial smaller. If I went straight to the X with the original problem, I'd have to do 3 times negative 36 and put that on top. And that's going to be a really big number, like in the hundreds. By factoring out my 3, I now have very nice small numbers. In fact, I don't even have a number in front of my x squared anymore because we're not going to count the GCF as a number because it's on the outside of the parentheses. So now for my x, I'm going to do the negative 12 on top and the 4 on the bottom. For this question, my 2 numbers on the side are a positive 6 and a negative 2. 6 times negative 2 is negative 12. 6 minus 2 is 4. Now you'll notice that I did not draw a box on this problem. The reason why is if there's no number in front of your x squared, the box is unnecessary. It's not needed. The box is only needed if you have, it's called a leading coefficient. If there's a number in front of your x squared, so if there had been no GCF on this problem and I had 3x squared right here, I would have had to use the box. Because I'm actually just factoring this trinomial and there's no number right here, I can go straight to my answer. And basically what you do is each number on the side of the x gets its own parentheses with an x in front of it. And so for my final answer, I'm going to have an x plus 6, right, from this side, and an x minus 2 from this side. And I don't want to forget, I need to keep my GCF as part of my answer, so I'm going to keep that number 3 in the very front of the problem. So don't forget your GCF all the way up in the front. So again, this can only be done if there's no number in front of the x squared. So if you look back at our previous examples, on example 1, the box was unnecessary. If you look at the sides of the x, they were actually the same numbers that were in the parentheses. But if you look at example 2, that had the 3 in front, the box was required. And if you look at your parentheses, they were a little bit more complicated. All right, these last 2 examples, which I want you to write down in your notes and try, they're actually trying your own. So go ahead and pause the video, try them by yourself, and then I'll reveal the answers once you're ready. So pause and come back. I hope that you had a chance to try both of these questions, and let's go ahead and check and see how you did with your answers. Now, on number 4, the box was not required because there's no number right here. If the letters were confusing, you can always use the box if you want to. Just because it's not required doesn't mean you can't use it. And here's the final answer that I got for this problem. Notice that in the front of each parentheses, there's a letter x. That's because the problem started with an x squared. And at the end of each parentheses, there's a y, and that's because it ended with y squared. Now on number 5, you did need to use the box because there was a 3 right here, and there was no GCF on that one. If you are having trouble with your x, you can always use a number and 1, a number and 1. So on this one, the sides of the x were 9 and 1. 9 times 1 is 9, and 9 plus 1 is 10. And here's my final answer. Again, notice there's no number 9 in my parentheses, so even though the side of the x had a 9, the parentheses don't, and that's why the box is required on this one. This concludes our only video for today, and then tonight's homework is going to be all Xbox problems with a little bit of GCFs sprinkled in there.